Welcome to MindXY, your channel for logical thinking and puzzle solving. We are told that two real numbers, x and y, satisfy these conditions. X plus y equals 5. X times y equals -3. We need to find the value of the expression e equals x plus x cubed over y squared plus y cubed over x squared plus y. At first, this looks complicated. Those cubes and squares can seem intimidating, but don't worry. We'll uncover structure hidden inside. Look closely. We have two similar parts, x cubed over y squared and y cubed over x squared. Each involves cubes on top and squares below. That repetition means symmetry, a sign we can group terms cleverly. Let's group the first and last terms together. That gives e equals x plus y plus x cubed over y squared plus y cubed over x squared. We already know that x plus y equals 5, so that part becomes simple later. Now our focus is on the fraction portion, x cubed over y squared plus y cubed over x squared. Let's find a common denominator. The denominators are y squared and x squared, so their common denominator is x squared y squared. Multiply each term accordingly. X cubed over y squared becomes x cubed x squared over x squared y squared, which is x to the power of 5 over x squared y squared. Likewise, y cubed over x squared becomes y to the power of 5 over x squared y squared. Add them together, x cubed over y squared plus y cubed over x squared equals x to the power of 5 plus y to the power of 5 over x squared y squared. Now our full expression becomes e equals x plus y plus x to the power of 5 plus y to the power of 5 over x times y squared. That's a much neater structure, just two big parts. We already know x plus y equals 5, and we know x times y equals -3. Computing x to the power of 5 plus y to the power of 5 directly would be hard. Instead, we use a recurrence pattern. Let's define u sub n as x to the power of n plus y to the power of n. The pattern is u sub n equals x plus y times u sub n minus 1 minus x times y times u sub n minus 2. This lets us compute each power step by step, using only addition and multiplication. We start small. U sub 0 equals x to the power of 0 plus y to the power of 0 equals 2. U sub 1 equals x plus y equals 5. Now step forward using the rule. U sub 2 equals x plus y times u sub 1 minus x times y times u sub 0. That's equals 31. Next, u sub 3 equals x plus y times u sub 2 minus x times y times u sub 1. That's 170. Then, u sub 4 equals x plus y times u sub 3 minus x times y times u sub 2, which gives us 943. Finally, u sub 5 equals x plus y times u sub 4 minus x times y times u sub 3 equals 5,225. So x to the power of 5 plus y to the power of 5 equals 5,225. Now, substitute everything back into our formula. E equals x plus y plus x to the power of 5 plus y to the power of 5 over x times y squared. Replace x plus y with 5, x times y with -3, and x to the power of 5 plus y to the power of 5 with 5,225. E equals 5 plus 5,225 divided by 9. Compute the fraction. 5 equals 45 divided by 9. Add 45 plus 5,225 equals 5,270. So E equals 5,270 divided by 9. We've found our result. E equals 5,270 divided by 9. We reached it through a single structured method, defining u sub n as x to the power of n plus y to the power of n and applying its recurrence relation. This approach demonstrates how recognizing symmetry and using recurrence transforms a daunting algebraic expression into a clean, logical result. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.